and complete a full two-mean hypothesis test with population standard deviation known, using the critical value approach. Now, when you look at a problem and you notice that it's rather large and there's a lot of information, don't let that overwhelm you. As you read through the question, write down what you know or what they're giving you. This will allow you to keep your notes concise, organized, and then help you work through the problem step by step. Let's go. A sociologist is studying how communication methods have changed over the years due to technology. Specifically, the sociologist would like to compare time spent talking on a cell phone during 2 different years. In 2015, 200 people were sampled. The average time spent communicating on a cell phone was 166.94 minutes per day, with a known standard deviation of 36.41 minutes per day. In 2018, another 200 people were sampled. During this year, the average time spent communicating on a cell phone was 176.46 minutes per day, with a known standard deviation of 27.54 minutes per day. Whew, it's a lot of information. So is there sufficient evidence at alpha equals 0.01 to show that the average time spent communicating on a cell phone per day was less in 2015 compared to 2018? Let's use 2015 as the first sample and 2018 as the second sample. So we are comparing two means here. Let's work through the test procedure and interpret the results of the hypothesis test. First, let's recall those steps. First, we're going to identify the null and alternative hypothesis. Then we'll decide on the significance level. We'll compute the test statistic. We'll find the critical value. And then we'll use that information to interpret the results of the hypothesis test. Let's jump in and have some fun. First, identifying the null and alternative hypothesis. So we're going to use 2015 as sample 1, 2018 as sample 2. And since we want to test if sample 1 was less than sample 2, we're going to use the less than symbol for the alternative hypothesis. Remember, the null hypothesis is always the equality piece. So in this case, mu sub 1, 2015, is equal to mu sub 2, 2018. For the alternative hypothesis, again, because we're dealing with less than, 2015 was less than 2018, mu sub 1 will be less than mu sub 2. And again, we're using the less than sign, so this will be a left-tailed test, just for future knowledge. Let's decide on the significance level. Well, we're given the significance level in the question, so we know that alpha equals 0.01. Now comes the fun part of the test statistic. It will be easier for you if you can recognize what is the formula that I'm working with here. Now we know the population standard deviation is known, so I'm going to be using a z-test statistic here. And you can see anything with a little sub 1 after it means it's coming from 2015, that first sample. Anything with the sub 2 at the end, that's coming from our second sample, 2018. So we know our formula. We then go to our information and we find our values. So as you were reading through that problem, I hope you wrote down the important pieces of information. So we notice the mean from 2015, x bar sub 1, the mean from 2018, x bar sub 2, and so on and so forth. You do notice that the two sample sizes, so n sub 1 and n sub 2, were both 200, so they're equal because they're both 200. Now that I have the formula and I have my values identified, I can substitute those values into the given formula. It's going to be very important that you use the order of operations. If you're typing all of this into your calculator, make sure you use parentheses where appropriate. You just want to make sure that the order of operations are followed. Otherwise, you might get a weird number that's not going to make any sense. So following the order of operations, we find our test statistic to be negative 2.95. Great. So I've got my test statistic. Now I can move on to find the critical value. We know this is a left-tailed test with a significance level of 0.01. Left-tailed test means the critical value is going to be negative because it's on the left side of that normal distribution curve. So I go to my table or whatever you have for your critical values, and we know that a one-tailed test with a significance level of 0.01 is going to have a critical value of 2.326. Again, because it's left-tailed, we're going to have a negative critical value of negative 2.326. Now that I have all of that information, I am ready to interpret the results of the hypothesis test. In this example, the test statistic of negative 2.95 is less than the critical value of negative 2.326. That means the test statistic is going to fall in the rejection region. Therefore, the conclusion is to reject the null hypothesis. How do we interpret that? At the 1% significance level, the data provides strong evidence to show that the average time spent communicating on a cell phone per day was less in 2015 compared to 2018. Step by step, and you'll get the results you want.